Good morning. ನೀವೆಲ್ಲ ಇಂಜಿನಿಯರಿಂಗ್ ಓದ್ತಾ ಇದ್ದೀರಲ್ವಾ? ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಅಂದ್ರೆ ವಾಪಸ್ ಒಂದು ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಹೇಳಬೇಕು.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್.
ಅವೆಲ್ಲ ಡೆವಲಪ್ ಮಾಡ್ಕೋಬೇಕು. ನೆನ್ನೆ ಹೇಳ್ಬಿಟ್ಟಿದ್ದೆ 4th ಪ್ರಾಬ್ಲಮ್ ಅಲ್ವಾ? Okay. Next we'll start with 5th one. Show that these two curves intersect each other orthogonally. Show that the two given curves intersect each other orthogonally. Let's consider first one. First curve. R is equal to A into 1 minus cos theta. R is equal to A into 1 minus cos theta. What is the approach? Apply log on both sides. The resultant will be log R is equal to log A into 1 minus cos theta. Log A into 1 minus cos theta takes log M into N form. That can be written as log A plus log 1 minus cos theta, because log M into N is log M plus log N. Now differentiate both sides with respect to theta. Differentiate both sides with respect to theta. Derivative of log R is 1 by R into dr by d theta. Here log A is a constant, its derivative will be 0. And derivative of log 1 minus cos theta is 1 over 1 minus cos theta into derivative of 1 minus cos theta is sin theta. Collectively it is sin theta divided by 1 minus cos theta. Sin theta divided by 1 minus cos theta. To simplify further, let's write sin theta as 2 sin theta by 2 into cos theta by 2. This is called half angle expression. And 1 minus cos theta can also be written as 2 sin square theta by 2. Cancel this 2 with this 2 and sin theta by 2 with 1 sin theta by 2 here. Now we are left with cos theta by 2 divided by sin theta by 2, which can be written as cot theta by 2. And 1 by r into dr by d theta is denoted by cot phi 1. This is equal to cot theta by 2. Clearly phi 1 is equal to theta by 2. Next, let's consider second equation. Second one. R is equal to 2a cos theta. Same approach. Take log on both sides. Log R is equal to log 2a cos theta. And log 2a cos theta, clearly it takes log m into n form, which can be written as log m plus log n. That is log 2a plus log cos theta. Now differentiate both sides with respect to theta. Derivative of log R is 1 by r into dr by d theta. And this log 2 is a constant, its derivative must be 0. And derivative of log cos theta is 1 over cos theta. And that of cos theta is minus sin theta. That is minus sin theta divided by cos theta. That can be written as minus tan theta. Now 1 by r into dr by d theta. This is denoted by cot phi 2. And this function is to be expressed in terms of cot. How do you write that? Minus tan theta is equal to cot pi by 2
plus theta.
plus theta. That's right. cot pi by 2 plus theta is equal to minus tan theta, or minus tan theta is equal to cot pi by 2 plus theta. Therefore, cot pi by 2 plus theta. Clearly, phi 2 is equal to pi by 2 plus theta. Rest is very simple. We have phi 1 and we have phi 2. Phi 1 and phi 2. Take the difference. Phi 1 is theta by 2 and phi 2 is pi by 2 plus theta. Therefore, angle between the two curves, magnitude of phi 1 minus phi 2 is equal to phi 1 is pi by 2 minus phi 2 is pi by 2 plus theta. You take the difference. Theta by 2 minus theta is theta by 2. Right here. Theta by 2 minus theta is minus theta by 2. Correct? Theta by 2 minus theta is minus theta by 2 minus pi by 2. Angle between the two curves is minus theta by 2 minus pi by 2, and absolute value of this angle is theta by 2 plus pi by 2, or pi by 2 plus theta by 2. In either ways, you can write that. Let this be equation number 1. Equation number 1. Now we shall find the value of theta. This is the given problem. R is equal to A into 1 minus cos theta and R is equal to 2A cos theta. LHS of both the equations are same. We can equate RHS. That means A into 1 minus cos theta is equal to 2A cos theta. Now cancel this A with this. 1 is equal to 2 cos theta is there on left right hand side. Now transform this minus cos theta to RHS, that will be plus cos theta. 2 cos theta plus cos theta is 3 cos theta is equal to 1. Therefore, cos theta is equal to 1 divided by 3. Or theta is equal to cos inverse 1 by 3. Substitute in equation number 1. Equation number 1 is pi by 2 plus theta by 2. Therefore, pi by 2 plus theta, theta is cos inverse 1 by 3 divided by 2. This is a question paper problem. Examination ಬಂದಿರುವಂತ problem ಇದು. You make a note of this. Is this over?
Yes, sir.
Okay. Next. Show that the following pair of curves intersect each other orthogonally. Same kind of problem. You find phi 1, phi 2 and take the difference, and difference must be pi by 2. Same kind of problems. First one, R is equal to A into 1 plus cos theta and R is equal to B into 1 minus cos theta. It's a very simple problem. Consider R is equal to A into 1 plus cos theta. First curve. Take log on both sides. Log R is equal to log A into 1 plus cos theta. Log R is equal to log A into 1 plus cos theta, and this takes log M into N. This can be written as log M plus log N. Now differentiate both sides with respect to theta. Derivative of log R is 1 by R into dr by d theta. Derivative of log 1 plus cos theta is 1 over 1 plus cos theta into Derivative of 1 plus cos theta is minus sin theta. That is minus sin theta divided by 1 plus cos theta. Keep this negative sign as it is, and this sin theta can also be written as 2 sin theta by 2 into cos theta by 2, and denominator 1 plus cos theta is 2 cos square theta by 2. Cancel this 2 with this 2. And here cos theta by 2 with 1 cos theta by 2 here. What's left now? Minus this negative sign. Sin theta divided by cos theta by 2 is tan theta by 2. And this trigonometric function is to be expressed in terms of cot. How? Minus tan theta is equal to cot pi by 2 plus theta. Minus tan theta is equal to cot pi by 2 plus theta. This is minus tan theta. This is theta now. This is equal to cot pi by 2 plus theta. Theta is theta by 2. And 1 by r into dr by d theta is denoted by cot phi 1. This is equal to cot pi by 2 plus theta by 2. Therefore, phi 1 is equal to pi by 2 plus theta by 2. Phi 1 is pi by 2 plus theta by 2. This is with respect to first curve. Now we shall consider second curve. Second curve, r is equal to b into 1 minus cos theta. Take log on both sides. Log r is equal to log b into 1 minus cos theta. Therefore, log r is equal to, now it takes log m into n form, that can be written as log m plus log n. Now differentiate both sides with respect to theta. Derivative of log r is 1 by r, and that of r is dr by d theta. This is equal to derivative of log 1 minus cos theta is 1 over 1 minus cos theta. And derivative of 1 minus cos theta. 1 is constant, its derivative is 0. Derivative of minus cos theta is sin theta. That is sin theta divided by 1 minus cos theta. To simplify further, this sin theta can be written as 2 sin theta by 2 into cos theta by 2, and 1 minus cos theta is 2 sin square theta by 2. Now cancel this 2 with this 2, and this sin theta by 2 with sin theta by 2. Cos theta by 2 divided by sin theta by 2 is cot theta by 2. 1 by r into dr by d theta is cot phi 2. This is equal to cot theta by 2. Therefore, phi 2 is theta by 2. Now take the difference. Magnitude of phi 1 minus phi 2. Substitute phi 1, phi 2 and simplify. We must get pi by 2. Magnitude of phi 1 minus phi 2 is magnitude of, what was phi 1? Phi 1 was pi by 2 plus theta by 2 minus phi 2 is theta by 2. Cancel this theta by 2 with this minus theta by 2. We get pi by 2. Radians are 90 degrees. Therefore, the two given curves intersect each other orthogonally. You make a note of this. If it is over, I will move on to the next slide. Next, r is equal to a into 1 plus sine theta and r is equal to a into 1 minus sine theta. Consider r is equal to a into 1 plus sine theta. This is first curve. Take log on both sides. Log r is equal to log a into 1 plus sine theta. It takes log m into n form. Log m into n, that can be written as log m plus log n. Log a plus log 1 plus sine theta. Now differentiate both sides with respect to theta. And derivative of log r is 1 by r into dr by d theta. This is equal to, here log a is a constant, its derivative must be 0. And derivative of log 1 plus sine theta is 1 over 1 plus sine theta. And derivative of 1 plus sine theta is cos theta. Cos theta divided by 1 plus sine theta. Further, you cannot simplify this. Therefore, 1 over r into dr by d theta is cot phi 1, and keep this RHS as this. Cos theta divided by 1 plus sine theta. We cannot simplify this further. We cannot express phi 1 separately. In such cases, convert this cot into tan. Take the reciprocal. Cot phi 1 is equal to cos theta divided by 1 plus sine theta, and it is reciprocal. Tan phi 1 is equal to, you just interchange numerator into denominator and denominator into numerator. That is 1 plus sine theta divided by cos theta. Let's keep that result as this and consider second curve. Consider a second curve. Second curve is r is equal to a into 1 minus sine theta. Take log on both sides. Log r is equal to log a into 1 minus sine theta. Clearly it takes log m into n form, that can be written as log m plus log n. Now differentiate both sides with respect to theta. Derivative of log r is 1 by r into dr by d theta. Here log a is a constant, its derivative is 0. Derivative of log 1 minus sine theta is 1 over 1 minus sine theta. I'm sorry, 1 over 1 minus sine theta, not cos theta. Derivative of log 1 minus sine theta is 1 over 1 minus sine theta into derivative of 1 minus sine theta is minus cos theta. That's what I have written here, minus cos theta divided by 1 minus sine theta. And 1 by r into dr by d theta is cot phi 2. This is equal to minus cos theta divided by 1 minus sine theta. In this case also, we cannot express this phi 2 separately. In such cases, we take the reciprocals. Cot phi 2 is equal to this much. Therefore, it's a reciprocal. Tan phi 2 is equal to minus into, you interchange numerator into denominator and denominator into numerator. That is minus into 1 minus sine theta divided by cos theta. Now let's consider tan phi 1 into phi 2, tan phi 2. Tan phi 1, we just obtained that tan phi 1 is 1 plus sine theta divided by cos theta into tan phi 2 is minus 1 minus sine theta divided by cos theta. 1 plus sine theta, 1 minus sine theta takes a plus b into a minus b form, that can be written as a square minus b square, that is 1 square minus sine square theta, which can be written as cos square theta. You keep this negative sign as this. 1 minus sine square theta is cos square theta, and cos theta into cos theta is cos square theta. So what's remaining now? Minus 1. What we put here is product of the two slopes m1 into m2 is equal to minus 1. Tan phi 1 is m1 and tan phi 2 is m2. m1 into m2 is equal to minus 1. Therefore, the two given curves intersect each other orthogonally. Is this clear?
Yes, sir.
Okay.
Yes,
You make a
sir.
note of this. If you finish, I'll move on to the next slide. It is over. We'll move on to the next problem.
Sir, can we actually simplify that that term, sir? Cos theta by minus cos theta by 1 minus sin theta.
Minus cos theta by 1 minus this one. How do you simplify?
Yes, sir. That.
How?
Sir, we can write that cos theta like cos square theta by 2 minus sin square theta by 2. And the denominator,
yes, that can be done.
written
That
as,
can be done. Yes. 1 can be written as sin square theta by 2 plus cos square theta by 2 minus sin theta is 2 sin theta by 2 cos theta by 2. It takes a minus b whole square form. X.
Yes, sir. We can do that, sir.
Yes, sir. You can do that also.
Okay.
But this is much easier, right?
Yes, sir. That goes a little lengthy.
Yes. Now try this one. R square sin 2 theta is equal to a square and r square cos 2 theta is equal to b square. You solve this on your own. Do not see this solution. Store.
Yes,
Phi
sir.
1 is minus 2 theta and phi 2 is pi by 2 minus 2 theta. And difference is pi by 2. Next. Padal equation of a polar curve. Padal equation means it is an equation corresponding to a polar curve expressed in terms of P and R. It is an expression corresponding to a given polar curve in terms of P and R. P is the shortest distance between the tangent to the polar curve from the pole. See, this is the curve and this is the tangent, and the shortest distance is perpendicular length. This is denoted by small letter P, and R is radius vector. An equation corresponding to the given polar curve expressed in terms of these two is called a Padal equation, P and R. Or it is also called as PR equation. In either ways you can call this Padal equation or PR equation. Length of the perpendicular means this P. This is the length of the perpendicular to the tangent from the pole. Length of the perpendicular from the pole to the tangent. This is tangent. T-A-N-G-E-N-T. Yes. Length of the perpendicular from the pole to the tangent. First, we shall construct this diagram. We consider any arbitrary curve like this. Any arbitrary curve. R is equal to f of theta. Any arbitrary curve. And this is the, to sketch the figure, this is the initial line. Now draw the tangent to the curve like this. Tangent to the curve. Next, radius vector. Radius vector will be like this. This is the radius vector. This is the perpendicular distance RP. We usually denote this angle by theta. This is angle between radius vector and tangent by phi. And this angle is denoted by psi. Let this point be O and this be N, and this is obviously this is P. This is R. This is the diagram. Let O be the pole and OL be the initial line. This is O and this is OL. Let O be the pole and OL be the initial line, and P of R comma theta be, this is the point. P of R comma theta be any arbitrary point on the curve. And OP is the radius vector. This is the radius vector, this line segment directed towards this P. Now draw ON perpendicular to the tangent at P. This is P. Draw ON perpendicular to the tangent drawn at this point. This is small letter P. Now from this, clearly this is a right angle triangle. Since this is perpendicular, this angle is a right angle. The side which is opposite to right angle is called hypotenuse. This is hypotenuse. From this triangle, sin phi. How do you write sin phi? This is the angle sin phi. Sin is opposite divided by hypotenuse. Corresponding to this angle, which is the opposite side. This is the opposite side, P. Divided by hypotenuse. Hypotenuse is denoted by R. Sin phi is equal to P by R. From the right angled triangle ONP, sin phi is equal to P by R. This can also be written as P is equal to R into sin phi. P is equal to R into sin phi. This is the length of the perpendicular. This is length of the perpendicular from pole to the tangent P is given by R is equal to sin phi. P is equal to R sin phi. Since P is equal to R sin phi, you take the reciprocal square of this expression. That is 1 by P square is equal to 1 by R square into 1 by sin square phi. Reciprocal square. 1 by P square is equal to 1 by R square into 1 by sin square phi. And 1 by sin square phi, sin is the reciprocal of cosecant. Therefore, 1 by sin square phi can be written as cosecant square phi. And keep this 1 by r square as this. This is equal to 1 by r square into cosecant square theta is always equal to, this is phi naught theta. Yes, cosecant square phi is equal to 1 plus cot square phi. This is equal to 1 by r square into 1 plus cot square phi. We know that cot phi is equal to, what is the expression to find cot phi? 1 by r into dr by theta. ಇದೆಲ್ಲರಿಗೂ ಗೊತ್ತಾಗಿದೆ, ಸಾಕಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಯ್ತು ಈಗ. Cot phi is equal to 1 by r into dr by d theta. Therefore, cot square phi is equal to 1 by r square into dr by d theta whole square. That is substituted here. Therefore, 1 by p square is equal to 1 by r square into 1 is 1 by r square plus 1 by r square into 1 by r square is 1 over r power 4 into dr by d theta. Clearly, this expression is expressed in terms of p and r. Therefore, this is a pedal equation. This is a pedal equation. Is this clear? For your doubts, you can unmute yourselves and ask, or put it in the chat box or message. Mark your attendance now. Next, working procedure. To find pedal equation, you will be given a polar curve and you have to find corresponding pedal equation. You have to perform 3 steps. First step is finding phi. You know how to find phi, angle between radius vector and tangent. And in the second step, substitute in p is equal to r sin phi. P is equal to r sin phi. You will get an equation in this type. P is equal to r into g of theta. You get an equation of this type. P is equal to r into g of theta. And in the second step, use the given expression. Given expression is given problem, and this obtained equation eliminate theta. That resultant will be a pedal equation. So you have to perform 3 steps. First step is a known step. Find phi, angle between radius vector and tangent. And in the second step, substitute phi in p is equal to r sin phi. Resultant will assume the form p is equal to r into g of theta. And from that equation and the given problem, you have to eliminate theta. That will be the third step. And the resultant is called a pedal equation. We'll solve a problem. We'll come to know how to find these pedal equations. Find the pedal equation of the following curves. Find the pedal equation of the following curves. First problem. 2a divided by r is equal to 1 plus cos theta. 2a divided by r is equal to 1 plus cos theta. What is first step? Finding phi. To find phi, take log on both sides. You know this. Log 2a divided by r is equal to log 1 plus cos theta. Log 2a divided by r is equal to log 1 plus cos theta. Now this takes log m by n form, which can be written as log m minus log n. Log 2a minus log r. This is equal to log 1 plus cos theta. Now differentiate with respect to theta. Log 2a is a constant, its derivative will be 0. Minus, you keep this negative sign as this. Derivative of log r is 1 by r into dr by d theta. This is equal to derivative of log 1 plus cos theta is 1 over 1 plus cos theta. Into derivative of 1 plus cos theta is minus sin theta. That's what I have written here. Minus sin theta divided by 1 plus cos theta. To simplify further, you keep this negative sign as it is here. Sin theta can be written as 2 sin theta by 2 into cos theta by 2 divided by 1 plus cos square cos theta can be written as 2 cos square theta by 2. Cancel this 2 with this 2. Cos theta by 2 with 1 cos theta by 2 here. And this negative sign is carried here. Sin theta by 2 divided by cos theta by 2 is minus tan theta by 2. And we know that minus tan theta is equal to cot pi by 2 plus theta. Here theta is theta by 2. Therefore, this can be written as cot pi by 2. This is plus. Correct? Minus tan theta is cot pi by 2 plus theta. That's correct. So one negative sign is here. I'm sorry. Minus 1 by r into dr by d theta is equal to minus tan theta by 2. You cancel this negative sign with this negative sign. You cancel this negative sign with this negative sign. Now 1 by r into dr by d theta is denoted by cot phi, and this negative sign is cancelled. Tan theta by 2. Now this tan theta by 2 is to be converted into cot. Tan theta is equal to cot pi by 2 minus theta. It falls in first quadrant, and in first quadrant all ratios are positive. Here theta is theta by 2, therefore cot pi by 2 minus theta. Theta is theta by 2. Therefore cot phi is equal to cot pi by 2 minus theta by 2. Therefore phi is equal to pi by 2 minus theta by 2. This is first working rule. Next, second working rule. What is second working rule? Substitute in p is equal to r sin phi. We just derived this expression. P is equal to r sin phi. Therefore, p is equal to r into sin phi, and phi is pi by 2 minus theta by 2. This is equal to r into pi by 2 is odd multiple of 90. In such cases, the trigonometric ratio changes into its co-ratio. That means sin changes to cos, and angle is theta by 2. Pi by 2 minus theta by 2 lies in first quadrant, and in first quadrant all ratios are positive. That means sin pi by 2 minus theta is equal to cos theta. This is a diagonal. Sin pi by 2 minus theta is equal to cos theta. Here theta is theta by 2. Therefore r cos theta by 2. Therefore p is equal to r into cos theta by 2. This is second working rule. What is third working rule? Third working rule is using this equation and the given problem, eliminate theta. Eliminate theta. This is equation number 1. Given problem is 2a divided by r is equal to 1 plus cos theta. 2a divided by r is equal to 1 plus cos theta can be written as 2 cos square theta by 2. You just cancel this 2 with this 2. Therefore, a by r is equal to cos square theta by 2. A by r is equal to cos square theta by 2. Therefore, a by r is equal to, from equation number 1, cos theta by 2 is equal to p by r. Cos theta by 2 is equal to p by r. Therefore, cos square theta by 2 is equal to p square by r square. P square by r square. From equation number 1 and 2, we obtain this expression. Therefore, a into r square divided by r is equal to p square. A into r square divided by r is equal to p square. Cancel this r with this r. Therefore, p square is equal to ar. This is what we call pedal equation. Do it fast. We are running out of the time. We terminate at any time. P square is equal to AR. Clearly, it is expressed in term of P and R. There will be no involvement of theta. Theta is eliminated. Such an equation is called pedal equation. Is it over?
Yes, sir.
Okay. Let's continue the next session. Okay. That is on Monday. Oh, tomorrow we have class, right? We'll continue tomorrow.